shows that this inequality holds true. 11 is strictly less than 1 plus half plus 1/3 plus all the way up to 1 over 10 to the 6th is strictly less than 19. I'm going to estimate this value using integral. So here's 0. Here's 1, 2, 3, 4. And f of x is 1 over x. So the graph will look like this. So I'm looking at this area, right? It says one, two, three, and so I'm looking at this area, this rectangle, and also this rectangle, and also this rectangle. And so that perhaps I'm going to draw and also this rectangle. Here's n plus 1. So the sum of these rectangles, the area, is definitely bigger than the area under the curve from 1 all the way up to n plus 1. Right? So I'm just gonna so the area of this sum of the rectangles, the width of the rectangle is 1. Right? Every rectangle, the width is 1. The height would be the functional value. Functional value taken at the left edge of each small interval. Right? Left edge, left edge, left edge. Right? And function is this. Right? So that is 1 over 1, right? The height of the rectangle times 1 plus 1 over 2. That's the height of the second rectangle times 1. Likewise, plus 1/3 plus the last rectangle, right? The left edge, n, right? F of n is 1 over n times 1. Just a little bit bigger than the area under the curve from this point up to this point. The definite integral from 1 up to not n, but n plus 1, right? N plus 1, up to here. And f of 1 over x dx. At the same time, I'm looking at then I'm going to have a look at this, the area of this rectangle. Also the area of this rectangle and the area of this rectangle, area of this rectangle. Right? I'm looking at the sum of the area of these rectangles. Right? And perhaps so up to here, up to this point, right? This rectangle, this rectangle, this rectangle, this rectangle. What's the? So this rectangle, right? So the width is 1, height is still f of 1, f of still 1, right? This rectangle, the height is. I'm going to take the functional value at the right edge of this interval, right? And also, for this interval, I'm going to take the functional value at the right edge as well, right? Representing its height. Right? So here, 1 over 1, 1 over 2, 1 over 3, and so on and so forth. 1 over n. Still the same thing. Right? That's less than the area. Then the area first. first this area, right, this rectangle, then the area under the curve from this point up to this point. Okay, because this rectangle is a little bit smaller than the area under the curve, right, in this interval, and this small rectangle is a little bit less than the area in this interval under this curve, right, and so on and so forth, right. So from this point up to this point under the curve, right, from 1 to n, definite integral f of x dx. Right. The only difference is that here it's up to n plus 1, there it's up to n. Right. And of course, right, then plus 1. The 1 represents the area of this rectangle. Right. Right. It's the same as this value, 1. Right. And after I cancel out this one and this one, so essentially I'm saying that the sum from half up to 1 over n is strictly less than this area under this curve, right? So, like I said, the functional value taken at the right edge of this small interval, that is f of 2, right? That's 1 over 2. 1 over 2, 1 over 3, all the way up to 1 over n, right? Strictly less than this, right? The area under the curve from 1 to n, right? So here I'm looking at the log of x from 1 to 1 plus n. Less than 1 over plus up to 1 over n is less than the log x from 1 to n and plus 1. So this one is log of n plus 1. Right. Log 1 is 0. So this is log n plus 1. So n, in this case, n is 10 to the 6. Okay. So I'm looking at log of 10 to the 6 plus 1. Right there, on this end, I'm looking at log of 10 to the 6 plus 1. So if I can just loosen left hand side, right, make it a little bit smaller, right? See if I can loosen it all the way down to 11. Right hand side, I'm gonna make it a little bit bigger, but still smaller than 19. And the reason is because log of 10 to the 6 plus 1, right? Make it a little bit smaller. Right, log of 10 to the 6. Right? It's a little bit smaller. So there's no more 1 here. A little bit smaller. So that is 6 log 10. Can I make it further smaller? Can I replace log 10 with 2? Right? Is 2 smaller than log 10? Right? I ask this question, is 2 smaller than log 10? Okay. In other words, if I take e to the 2, is e to the 2 less than e to the log 10? Right, which is just 10. Right, is e to the 2 less than 10? Okay. In other words, e is a little bit bigger than 2.5, right? No, e is a little bit less than 3. Right? E is a little bit less than 3. So therefore, e squared is a little bit less than 9. And 9 is less than 10. Right? E squared is really less than 10. Right? So in other words, 2 is really less than log 10. Right? So I can make it a little bit smaller. 6 times 2, 12. Okay? 12 is bigger than 11. Right? I really losing the inequality, right, on this end, right? So really bigger than 11. Is it less than 19 at the same time, right? So can I loosen this end a little bit? So I'm looking at log log 10 to the 6, right? That is 6 log 10. So can I loosen log 10 just a little bit? Right? Log 10, is it less than 3? Right? That's my question. So is log 10 less than 3? In other words, is e to the power of log 10 less than e to the 3? Right? But that is just 10, right? Is it 10 less than e to the 3? So e is a little bit, so because e is a little bit bigger than 2.5, right? And so e to the power of 3 is a little bit bigger than 2.5 to the power of 3, right? But 2.5 squared is 6 point something, right? 6 point something times 2.5 is bigger than 12, right? That is a little bit bigger than 12. And also a little bit bigger than 10. Right? E cube is really a little bit bigger than 10. So in other words, yes, really true, right? E cube is really bigger than 10, right? So log 10 is really a little bit less than 3. So this is a little bit less than 6 times 3, 18, right? So e to the 10 to the log 10 to the 6 is smaller than 18, right? So this smaller than 19. So really smaller than 19 at the same time, bigger than 11.